Well, hello, everybody. I know this isn't as fancy as Mrs. Doll's, but we can't let her have all the fun. So I'm recording the notes for you guys today. Sorry, I'm not with you. So hopefully this is helpful. Natural logarithms. I mentioned yesterday that it is very, very similar to what we've been doing. So if I am a natural logarithm, all I am is base e. Remember, e is approximately 2.71828, blah, 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 right? It's found on your calculator on the left-hand side. But if I am a natural logarithm, all that means is I'm a logarithm with base e. It's just got a fancy name. It's the same. It has the same properties as logarithms, follows all the same rules, but now we're in base e. So your calculator has base 10. If you remember, you can see my log button right there, base 10, whereas it has ln. Now your guys's, if you have the TI's, is on the left-hand side still. Okay, and if we were to graph it, it is simply the inverse. So it's reflecting across y equals x. If I were to write down my parent function points for e to the x, we know that we have negative 1, 0.134, and then you've got 0, 1, and then you have 1, 2.72. Well, if I want to graph the natural log of x, it switches. Okay, again, all the same properties as inverses. Oops. Okay, and that's what the graph looks like. For those of you that don't have the printed out notes, you might want to copy that down. Pardon me. Okay, so example number 1, rewrite each expression as a single logarithm. So this is using the properties. Whenever you see a number in front of a log, you want to bump it up using the power property. So I'm going to rewrite this as the natural log of 2 to the third minus the natural log of x cubed. Go ahead and simplify 2 to the third. So that leaves us with the natural log of 8 minus the natural log of x cubed. Next thing, if we're writing it as a single logarithm, I need to use my quotient property. So that means I'm going to have the natural log of 8 over x cubed, and we've simplified as much as we can, so that's our final answer. Okay, for this guy, again, I see that there is a number in front of the logarithm, so I'm going to rewrite it as the natural log of 3 squared plus the natural log of 8. I can simplify 3 squared, so this is going to be the natural log of 9 plus the natural log of 8. Using the product property, because this is addition, we can combine through multiplication. Remember, the idea with the properties is to get one logarithmic term, okay, not keep it as 2. So this is now the natural log of 72. And that's a single logarithmic term. Good. All right, this guy, same idea. So there's numbers in front. I'm going to say the natural log of x to the 20th power plus the natural log of y to the 5th minus the natural log of z squared. Always work left to right, just like we read a graph, just like we read a book. So I'm going to combine these two into the natural log of x to the 20th, y to the 5th, minus the natural log of z squared. And then using the quotient property, I can combine it into 1, so the natural log of x to the 20th, little tiny 20, y to the 5th, all over z squared. And that is our one logarithmic term. Okay, nothing changes, you guys. Just because I'm throwing in a different base, a different terminology, different notation, doesn't mean any of the properties change. And we're going to solve it the same way. So we're being asked to solve the natural log of x is equal to 5. If it helps you, just rewrite it as log base e. It's the same thing. Okay, and this is going to help because if I have a logarithm on one side of the equal sign and a number on the other, my only option is to rewrite it exponentially. So base, exponent, answer. So e to the 5th is going to equal x. And let's round to the hundredths. I'm going to grab my calculator, turn it on. Sorry, my other TI is, it's mad at me. It's not working right. So I'm going to press e to the 5th, enter. And it is approximately 148.41. Make sure to approximate your equal sign. So 148.41. Yes, we have to check our answer because this is a logarithmic equation. But if I substitute that into x, I'm taking the logarithm of a positive number. So I'm good to go. All right, take a look at B. Again, same idea. I'm going to rewrite it. You don't have to. bit so I can get that visual. So it's just log base e of the quantity 6x plus 1 equal to 3. I have a logarithm on one side and not the other. So I'm going to rewrite it as e to the third is equal to 6x plus 1. Our goal is to solve. I don't want to approximate or round until the very end. So I'm going to isolate x. I'm going to subtract 1 to both sides. So 6x is equal to e cubed minus 1. Divide by 6. So x is equal to e cubed minus 1 divided by 6. Okay, when putting it into your calculator, please don't forget about your parentheses. So I'm going to put in a parenthesis to show my calculator I need my numerator calculated first. E cubed, oopsies, I need to arrow down to get out of that exponent spot, minus 1, close my parentheses, divided by 6. And I get approximately 3.18. And if I were to substitute it back into the original, I'm still taking the logarithm of a positive number. I'm okay. All right, last one. A couple things we could do here. So we have the log base e of the quantity 2x plus 1 squared is equal to 6. My inclination is to move that 2 down into the front using the power property. So I have 2 times the log base e of 2x plus 1 is equal to 6. Divide both sides by 2. So I have the log base e, or you can keep it as the natural log, of 2x plus 1 is equal to 3. Now, I'm exactly in that same situation where I was with the other ones, so rewrite it. I'm going to say e cubed is equal to 2x plus 1. We want to isolate x, so 2x is equal to e cubed minus 1. Last thing is divide by 2. So x is e cubed minus 1 divided by 2. Okay, when you put it in your calculator, again, we need to be careful. I'm going to, I'm going to go up and just re-enter my previous entry so that I can edit my denominator because they're exactly the same. And I get approximately 9.54. So x is approximately 9.54. Hopefully you guys are seeing that this is exactly what we've been doing, except we're now base what? Yep, base E. Hopefully that's what you said. Okay, example number 3. So now, do we have to check our answers for exponential functions? Or sorry, equations? No, because there aren't any limitations. For logarithms, I can't take the logarithm of 0 or a negative due to the definition of what a logarithm is. So we have to check those. Thankfully, for example 2, we were good to go for all of them. All right, solve A. I can't isolate the term with the exponent because it's already isolated. So I need to rewrite it in logarithmic form. That's my only option. So log base e of 24 is equal to x plus 3. We learned today, a few minutes ago, that the log base e is the natural log of 24 is equal to x plus 3. Go ahead and subtract 3 from both sides. So x equals the natural log of 24 minus 3. All right, putting it into our calculators. Natural log is on the left-hand side for you guys. My calculator, it's a second function. I think yours is not, if I remember correctly. Your e is your second function. So go ahead and press natural log of 24. Whoops, sorry guys. My calculator prompts me for a parenthesis, and then I'm going to subtract 3 from that value. You should get approximately 0.18. And don't forget to approximate your equal sign. Good. Okay, for B, I can isolate the exponential term. So go ahead and divide both sides by 5. So we get e to the negative 3x is equal to 9. Nothing else that we can move away from that term. So I'm going to rewrite it as the log base e of 9 equal to negative 3x. Remember, base answer exponent, duh. So base answer exponent. So then we have the natural log of 9 is equal to negative 3x divided by negative 3. So we get the natural log of 9 divided by negative 3. If we put that into our trusty calculator, I have the natural log of 9, close parenthesis, divided by a negative 3. Be careful with the negative. Make sure it's a negative, not a subtraction sign. And we get approximately negative 0.73. Beautiful. Okay. Yes, Taylor, it's beautiful. Go ahead and add 8 to both sides. So we get 2e to the 5x is equal to 38. divide both sides by 2, so we get e to the 5x is equal to 19. Just a reminder, why do we isolate this term? I can't put it into a logarithm like this. The power property doesn't apply because this is 2 times e to the 5x. If it was the power property, it would be the log, all right? So be careful, don't get those mixed up. So now we can write it as the log base e of 19 is equal to 5x. We get 5x is equal to the natural log of 19. X is the natural log of 19 divided by 5. Yay, we're almost there. So x is approximately, okay, here we go. Natural log of 19, I guess you guys could see it, sorry. Divided by 5. So we get approximately 0.59. Excellente. All right, last example, and then you can start homework number 9. Carbon dating is a method used to determine the age of organic material less than 50,000 years old. One of the formulas for carbon dating is given here, okay? And it tells us that N sub F divided by N naught is the percent of carbon-14 remaining. And then T is in years, okay? So very important information there. A fossil is found to have 30% carbon-14. So that means that this quotient can be substituted by 30%. And then they want us to find out what's the age of the fossil. So what are we looking for? We're looking for T, the time. Yeah, how old is this thing? Okay, so I'm going to say T is equal to the natural log of 0.3 divided by negative 0.693 times 5,700. Okay, just making sure you guys are caught up. So then I'm going to go ahead and put it into my calculator. Do it with me, please. So we have the natural log of 0.3 divided by negative 0.693. And then we're going to multiply that quotient by 5,700. And you should get, well, actually, we don't have to round this guy. We can say it's equal to 9,902.81 years. So it looked super crazy complicated with all of those words thrown at you in that paragraph. It's not. Okay, make sure that you identify what it tells you, and it tells us that this was the percent which we were able to substitute in, and then we were just solving from there. All right, guys, you now can complete homework number 9. If you need to rewind and go back on this video, you know that you can. And we're done with this unit. That went super fast. Whew. Yikes. All right, have a fantastic day.